Very good morning all the students. Today we will see the next numerical, which is also based on the structural matrix of a truss geometry. So as shown on the screen, this is a simple type of pin jointed truss is there. It is having the support A and B is a fixed support, okay, and member AC, AD and BC and BD and CD, DC are jointly connected. Okay, one important thing in this numerical is that this is the type of numerical in which the the member is identical. If you see along the CD axis, along the CD point, it is exact similar, or the member AC and AD, whatever the force will be calculated, you will going to calculate in this numerical, will be same for the member BC and BD, because it is symmetrical about y-axis. Now let us see how to calculate this numerical. First of all, we have to identify the unknown DOKI, that is degree of kinematic indeterminacy. So unknown DOKI will be formed at the joint C and D, because A and D are the fixed support. So let us start marking the coordinate from the unknown. So 1, 2, 3, 4 we can define here, then 5, 6, 7, 8 are the known coordinates. So DOKI will be 4. Next is the calculation of the member forces. So let us start with AD. So at AD the angle is given as 38.66. okay, so theta will be equal to 38.66. Cx is equal to cos theta, that is cos of 38.66, and Cy is the sin theta, sin of 38.66, that is equal to 0.62. Now in this case, a value of A is given, that is equal to 0.0064. E is not given. Length we can calculate as per the dimension. Length is given as 5.76. So we will get the value of A by L in the form of E. So you can put the value of 10 to the power minus 3E as outside the bracket. So what is the coordinate of AD? It is 7834. So you have to put this coordinate very carefully as per your member. AD is equal to 7834. Now you have to calculate the structural matrix as per the formula. Okay, so you will get the expressions like this. Okay, then you have to calculate and then go for the next member, that is AC. So AC theta is 53.13. if you see that, then you have to calculate the value of CXCY according to that theta. Then EA by L, A is given as 0.04 here, EA by L is given as 7.5. so you can calculate the value of EA by L in the form of E. Then put the value of this 10 to the power minus 3 outside the bracket in the form of E, and rest of the value inside the bracket you can calculate by using the formula. And the coordinate you have to put 7812 AC. We know that at AC the coordinate is 7812. Then similarly you have to calculate the value for the next member, that is BC. Angle is 180 minus 53.13. How this value will come, let us see. Okay, you have to calculate the value of BC. This is BC. So we know that as the angle is given as 53.13, but we know very well that we have to calculate the angle, okay, which have to measure from the anti-clockwise direction. Okay, so we have to measure the angle from left side, not from the right side, whatever the given value is there. So we know that 53.13 is already given. Okay, so BC we have to calculate. So we know that the half angle will be 180. So 180 minus 53.13. So whatever the answer is 141.34. That you have to use this 141.34 in your calculation of theta. Okay, so Cx is equal to cos of 741.34. The answer is minus 0.78. Cy is equal to 0.62. EA by L is equal to this 1.1 10 to the power minus 3 EA. Okay, put this value 10 to the power minus 3 E as outside the bracket. Write the respective coordinate for BD 5634, 5634. Calculate the structural matrix as per the formula. Then BC, again BC. Here BC is there. Now BC, for BC you have to use the value again 180 minus 38.66, then 180 minus 53.13, then you will get the answer is 126.87. Then CXCY you can calculate, EA by L you can calculate, and then accordingly you can form the structural matrix like this with respect to coordinates of 5612, 5612. Then member DC, so DC is the vertical member, so you can go for theta equal to 90, CXCY, okay, EA by L you can calculate. Then structural matrix we can form like this 3412, 3412. Then the formation of global load matrix. So we know that we have to calculate the DOKI, that is kinematic indeterminacy, at 1 2 3 4. So put this 1 2 3 4 as a row and column. Then carefully you have to calculate 1 1 2 1 3 1 4 1, then 1 2 2 2 3 2 4 2, and so on, based on the above calculated matrix operation. Okay, sum of value as per the requirement, and then you can calculate the value of K. Then AFC, then you have to calculate the AFC. AFC, what is the meaning of AFC? AFC means action of the force at the coordinate. So we know that we are having the unknown kinematic indeterminacy at 1 2 3 4. So you have to see that at that point what are the external load is acting. So at 1 there is no load, at 2 this 54 kilonewton load is there in the downward direction. So downward is nothing but minus. At 3 that is 0, at 4 that is 0. So let us see what he has written, 0 minus 54 0 0. Then the calculation of the displacement. K into DF is equal to AFC. K matrix you have to put DF, that is a displacement matrix. You have displacement values or the unknown displacement you have to put here, AFC you have to put here. Okay, then you will get the answer. Solve this simultaneous equation of 4 unknowns in your calculator. You will get the answer as df1 is 0, df2 is equal to minus 47.27 10 to power 3 by EI, df3 is equal to 0, df4 is equal to minus 25.41 10 to power 3 E. Then AM1, then the final forces. The final forces, the formula is EA by L, EA by L, EA by L minus EA by L, EA minus EA by L, and EA by L. Okay, AM1 represent the calculation of the force for the member AD. So AD we have already calculated, EA by L this value. Then CXCY 00, CXCY 00 value you have to put here. The respective coordinate of AD you have to put 7834. Okay, so 783 all are the 0 value, only 0.4 you have calculated the displacement as minus 25.41 you have to put here, 10 to the power 3 by E, here 10 to the power minus 3 E. So this minus 3 or this plus 3, and this numerator and denominator will get cancelled, and then finally by multiplying these two matrices you will get the answer as 17.48. Similarly you can calculate the value for AC, okay, AM2, then ABD, then BC and DC. Okay, now one thing is important in this case is whatever the final forces we have calculated, okay, you have to see that the first value, the symbol for the first value, as we know that the first value is having a positive sign. Okay, that means in matrix operation it is a tensile, but while writing in your representing this value in your diagram you have to put it as minus. So let us see where AD will come. So AD will come here like this, AD, so it is compression 17.48. Similarly for second case AC, it is also 20.04 and it is also tensile positive, so we have to put it here a minus. And in the start of the numerical I told you that whatever the value we will get on the left side, exact value we will get on the right side, as it is a symmetrical about the y-axis. This is a y-axis, so therefore this value and this value will be always same. If you will not get this value as same, that means that you have committed any mistake. Then the last value, what is the value for DC? It is 21.86. So it is also represent as a opposite size of compression in your diagram. Okay, so this was the numerical, and this type of numerical is also very much ask in your examinations. If you see your university exam papers of last 4 or 5 year, okay. So with the completion of this, I am completing the type 1 of this truss element, okay. So basically in the truss chapter of your structural matrix, there are 4 cases, or you can say that 4 types. So first case or first type we have already covered. In that case we have calculated the unknown displacement, and we have also calculated the unknown member forces for the truss. In the coming lectures we will start with type 2. So under that we will cover the formulation of the global matrix. So these numerical will be having the stiffness matrix of 6 by 6. So in that numerical you may be asked to solve or to formulate the global matrix of the equation for 6 by 6 matrix. You need not require to solve the displacement as well as the member forces in that numerical. Okay, you are only expected, the examiner is only expected to see that whether you have solved the global load matrix or not, because in numerical itself it is written as formulate the global load matrix for a given member. So as per the numerical statement you can easily judge that the type of numerical is for the global load matrix, and that numerical may be asked for only 7 marks. Okay, then the type of numerical is that in that case the numerical is having the lack of fit problems are there. So lack of fit is nothing but there may be always a case that a truss member is having a length. We know that the truss is having a length, and by default it may be too short or it may be too long while manufacturing. So these are the manufacturing defects. Okay, so in that case how to analyze that numerical if the member is having the length which is less as required by the dimension, or it may be too long. So that covers under the type number 3. And the last type is a temperature effect. So we know that we are dealing with a truss element, as the truss element are always manufactured with the material called steel, and we know better that the steel is subjected to the temperature effect. Okay, if the temperature is too high or if the temperature is too low, so there may be a chances of expansion and contraction in the steel structure. Okay, so what are the effect of that if temperature, because of too high temperature and too low temperature? So that we will cover in our type number 4. Okay, so we will cover these 3 types, okay, in our upcoming lectures. Okay, so thank you for your kind attention. Thank you.